Handout 4.4, page 2. Two vectors that meet at a 90-degree angle are said to be orthogonal. We don't call it perpendicular. We call it orthogonal. If v dot w equals 0, then the cosine of theta is 0, and theta equals 90 degrees. So make yourself a note. Cosine of theta equals 0, then this is orthogonal. You don't have to worry about your denominator, because if you got 0 in the numerator, you know that the whole value of the fraction is 0. That is the same as perpendicular. Two vectors are parallel when the angle between the vectors is 0 degrees or 180 degrees. If the angle between them is 0 degrees, the vectors are parallel and have the same direction. If theta is 180 degrees, the vectors point in opposite directions. So, if v dot w over the magnitude of v times the magnitude of w equals 1 or negative 1, they are parallel. But you got to work the whole thing out to figure that out. For the orthogonal, if you get a 0, anytime you're working these, if you get a 0 for v dot w, then you know right then that they are orthogonal. Homework 13 through 15. Use the dot product to determine whether v and w are orthogonal. So they didn't even make me do the whole thing. They just said find v dot w so you can answer if it's orthogonal or not. V dot w would be 11 times 11 plus 11 times negative 11. Definitely equals 0. Answer is yes. Homework 16 and 18. Decide whether these are parallel, orthogonal, or neither. So I'm going to first do v dot w. V dot w equals 4 times 6 plus negative 2 times 5. 24 minus 10 is 14. They're definitely not orthogonal. Now I got to do magnitude of v, which is the square root of 16 plus 4, square root of 20. Got to do the magnitude of w, which is the square root of 36 plus 25, which is the square root of 61. 14 over the square root of this is not equal to 1, and it's not equal to negative 1. Therefore, these are not parallel, they're not orthogonal, so they would be neither. The next problem looks similar to something that you would see on a physics test. The work W done by a force F moving an object from A to B on level ground. This is on level ground. This problem is on level ground. Is given by this. W equals F dot product A, B. That is the magnitude of F times the magnitude of AB times the cosine of theta. So it's the force times the distance and theta is the angle between the force and the direction of motion. The force is 20. They gave me that. The distance that they're moving that's 150 feet. The handle makes a 30-degree angle with the horizontal, so that's times the cosine of 30 degrees. When you put those three in your calculator and multiply, you get 2,598, and that would be in foot-pounds.